Okay, so after the combination of resistance and the factor affecting resistance, we discussed the formula last time. We also solved some practice questions related to the combination of resistance, that how to apply the formula of series and parallel combination. So after that concept of resistance, we have electrical energy and electrical power concepts also in electricity chapter. So if we talk about electrical energy, so the concept of electrical energy is also the same, ability to do work. So the formula is important. So for electrical energy, we use the formula E is equals to VIT. V represents the voltage or the potential difference. I represents electric current, and T represents time. And also we know that the SI unit of energy is always joules. J. So this is the unit of energy. And in the same way, if we consider electrical power, so the formula of electrical power is the basic general formula of power is energy or work done upon time. So energy is equals to VIT. So it becomes VIT over T. So T and T cancel out each other. So finally, power is equals to voltage into current, right? So this is the formula of electrical power. But you remember the formula of resistance. The formula of resistance we discussed already. R is equals to V over I. So we can use this formula to make other variants of this power formula. For example, if we consider one variation, so in one variation, if we replace voltage, so V is equals to IR. So for example, if we are using one variation, V equals to IR, so the formula of power will be equals to, on the place of V, we substitute IR into I. It becomes I square R, right? And in the same way, for example, if we substitute the value of I from the power formula, so I will be equals to V over R according to this resistance formula. So power is equals to V into V over R. So another variation of the power formula is V square over R. So these are two other variants of the formula of power. So we can use P is equals to VI. We can use P is equals to I square R. We can use P is equals to V square upon R. So depending upon the situation in the question, depending upon the quantities given in the question, we can use the formula of the power, right? So it depends. It is not compulsory that always we used to apply P is equals to VI. If you think that voltage and resistance is given in the question, So you can calculate power by using formula V square over R also, right? And if current and resistance is given, so we can use P is equals to I square R. So power can also be calculated with the help of these other two relation of power with the quantities given. If P is equals to VI not works in the question. So this is the concept of electrical energy and electrical power. So before that, okay. So if we apply this formula and the combination of resistance formula, factor affecting formula in the theory question. So we have theory question. So let's see how to apply these formula and these equation on the combination of resistance formula in the theoretical questions. Okay, so this is one theoretical formula. We can solve this complete formula by using the concepts of resistance, current, and energy and power formula. Question number 8. A cylinder is made of a modeling clay, and the modeling clay is an electrical conductor. So basically, we are using electrical conductor, so electric current can pass through this modeling clay. Then cylinder is connected to a circuit. It shows that circuit also includes a battery of EMF 9 volt and resistor P. So we have modeling clay and one more resistor P in the circuit with one battery of 9 volt EMF. Then the resistance of P is 4 ohms and the current in P is 1.5 ampere. So basically we know that in this circuit we have only one path. So current remains same throughout the circuit. So same current will flow throughout the circuit from every component. So current is same. Now the first part is calculate the magnitude of the charge that flows through P in 600 seconds. So first of all, we have to calculate the charge in 600 seconds. So which formula helps to calculate the charge? From the formula of electric current, the formula of electric current is I equals to Q upon T. So we can find out Q equals to IT. So Q is the charge. Electric current 1.5 times 600 seconds. So the value of charge is 900 coulomb. So this is the first formula we discussed in this chapter related to electric current. That gives you answer 900 coulombs for the charge. The second part is to calculate the resistance of the cylinder of modeling clay. So the formula of resistance R equals to V over I. So basically for the resistance of the modeling clay, the problem is voltage. If you remember the difference between EMF and potential difference, EMF is the voltage of the source. So from the source, we are getting 9 volt, but we have two components in the circuit. So potential difference for P and potential difference for the modeling clay will be different. Okay. So EMF is related to the load, to the cell, to the battery only. But if we talk about the potential difference across each component in the circuit, so that will be different. It depends. So first of all, we have to find out the voltage of P. So first of all, we are finding out the voltage of, sorry, they are talking about resistance. We know about the value of electric current. Yes. So basically, if we consider the voltage of P will be equals to electric current and resistance of P. So current is same in the circuit, that is 1.5, and the resistance of P is, this is the resistance of P, 4 ohms. 4 into 1.5 equals to 6. So basically in this circuit, the component P consumes 6 volt out of 9. So how much volt will be consumed by the modeling clay? 3 volts, right? Because there are total 9 volts of the battery, and out of 9 volts, 6 volts are consumed by the resistor P, and rest of the 3 volt is consumed by the modeling clay. Because in series combination, we discuss voltage divides. So voltage will not remain same in series combination. In series combination, voltage is the sum of individual values. So basically, now if we talk about the clay, the voltage of the clay will be equals to 9 volts minus 6 volts equals to 3. And to find out the resistance, so it is equals to 2 ohms. So the resistance of the modeling clay is equals to 2 ohms, right? Any confusion in this? Okay. Now, the B part of the question, this is slightly detailed because it is for 4 marks and it is based on calculation only. The now cylinder is removed now from the circuit and replaced with a new cylinder made up of same modeling clay. The new cylinder is twice the length and half the cross-sectional area of the first cylinder. So basically, it is twice the length of the first and half the cross-sectional area of the first. Now calculate the time that it takes for a charge of magnitude x to flow through resistor P, right? So now the question is we have to calculate the time, because in the first part of the question, 600 seconds time is given. So in 600 seconds, the 900 coulomb charge passed through the circuit. But now in B part, we have new cylinder with new dimension. Material is same, but dimensions are different. So their question is calculate the time it takes now for the same amount of charge to flow through resistor P. So already we have 900 coulombs charges passing in the first case. So we have to find out the time for the same number of the charges passing through resistor P, right? So first of all, we have to find out the new resistance, because we know that the previous resistance of the modeling clay is 2 ohms. Now we have to find out the new resistance of the new modeling clay first. So then we are able to find out the magnitude of the charge. So we use the same idea, just like the factor affecting resistance. Formula is R equals to L upon A. L2 is 2 times L1. A2 is 0.5 times A1. And 2 divided by zero point 0.5 is equals to 4. So basically R2 is equals to 4 times L1 over A1. And now we know that the value of raw L1 over A1 is equals to R1. So it becomes R1. And R1 is equals to 2 ohms. Eight ohms. So this is the new resistance of new modeling clay that we connect in the circuit. And now the second part is to find out the new value of electric current. So now we have to find out the new value of electric current. And to find out the new value of electric current, we use the formula, same the formula of resistance, R is equals to V upon I. So total resistance, total voltage, total current. Total resistance, total voltage, total current. So total voltage is 9 volt, just like the previous diagram, because volt remains the same. It is not changed in this B part. The value of current is unknown. And if we talk about total resistance, so total resistance means the resistance of P is 4, right? So the resistance of P is 4 and the new resistance of the cylinder is 8. So 4 plus 8 equals to 12. So the total resistance of the new circuit with new components is equals to 12 ohms. 8 plus 4. So the final value of the current is 0.75. Right? So this is the value of the new current in the circuit. And finally, we can find out the time because charge remains the same. The charges are equals to 900 divided by 0.75 is the value of current, 1200 seconds. So this
Sir,
is the hmm,
could you explain the part written purple once again?
okay, the part for electric current.
Yeah.
Okay. Basically, when we find out the new resistance of the cylinder, so in our circuit, basically we have only one change. Whole circuit remains the same. Like this is the battery we are using. This is the resistor P we are using. Only we replace the old cylinder with the new cylinder. This is the only difference, and rest of the circuit remains the same. So we find out the new resistance, and the new resistance of cylinder is 8 ohms. And already we are using fixed resistor in the circuit, which is equals to 4 ohms, just like mentioned in the first part of the question. And to find out the electric current, because in the first part, electric current is 1.5, and that 1.5 current is same throughout the circuit, because in series combination, current remains the same. So now we know that the value changes because in the old circuit, we have 2 ohms resistance of the modeling clay. So we operate that circuit on 1.5 ampere current. But now the value of resistance increases. And we know that according to this formula, the value of resistance increases means the value of current decreases. So previously we have 1.5 ampere current. So now in our new circuit, the value of resistance increases. So definitely the value of current decreases. So that's why we find out the new value of electric current. So the total current can be calculated by using the total value of resistance and the total voltage in the circuit. So the total resistance is equals to total voltage divided by total current. And for this total resistance will be equals to 8 plus 4. Because if you remember, when resistors are connected in series combination, so we have to add their resistance. So that's why we combine the resistance given in the diagram, right? To find out the total current and total resistance in the circuit. So the total resistance in the circuit is equals to 8 plus 4, that is 12. And the value of voltage remains the same because in this B part, the voltage is same. There is no change in the voltage. So that's why we got new value of electric current 0.75 amperes. Right? Any confusion?
No.
Because in theoretical questions, we have to know the idea of combination of resistors, the concept of EMF, potential difference. So all together we have to consider all concepts in single question. Like in this single question, we used to apply the formula of current, we apply the formula of voltage, and we use the concept of the combination of series and parallel combination also, right? So we are working with all the formula in one question. Okay. So that's why it is important to remember each and every idea that we discussed till now in resistance, current, and voltage, right?
Okay, got it.
And the second thing, last time we discussed the concept of the combination of resistance. Now, in different questions, for example, in this question, you can see we have different components also other than resistance. So there are some other components connected in the circuit also. So what are these components? We only discuss about resistance till now. We only know about the resistance, that component we used in the circuit, but there are some other components also. And to understand that component, we have to consider the topic of Ohm's law. So basically, Ohm's law tells you about the type of the conductors in which the value of voltage and electric current are directly proportional. For example, if we use normal wire, so if we use normal wire or normal type of copper, iron or silver conductor, so that will give you the concept of voltage and electric current both directly proportional. But if we use different type of components like diode, filament, LDR, LED, so that these components will give you different idea for voltage and electric current. So basically, Ohm's law tells you at constant temperature, the current flowing in a conductor is directly proportional to the potential difference across it. So basically, if we consider a wire, and let's suppose that wire is of any material, right? We don't know about the material, let's suppose. So if you observe that if you keep the temperature constant for that material, so the current and voltage both are directly proportional. So it means that conductor obeys Ohm's law, right? But for example, if uh, voltage and current are not directly proportional, so it means that the conductor will not follow Ohm's law, right? So the wire we used in our normal circuits like silver, iron, copper, so these conductors gives you Ohm's law because voltage and current are directly proportional in these normal conductors. So according to this idea, the formula will be V directly proportional to I, or V is equals to IR. So this is the equation for Ohm's law. V is equals to IR. This is the same equation like R is equals to V upon I. So this is the same type of equation that we are already using for the resistance formula. And conductors, that obeys Ohm's law are called ohmic conductors. So all the conductors that obeys Ohm's law are called ohmic conductors. And in ohmic conductor, if we draw the graphical representation, or if they used to ask with the representation of the graph, so you can also identify the ohmic conductor with the help of their graphical representation. So for example, this is the value of current, this is the value of the voltage, this is the resistance of one wire, this is the resistance of second wire. And you can see in both the resistors, or in the both wires, we have a straight line. It means in both concepts the voltage and current are directly proportional to each other, right? So basically, from graph, let's suppose if we want to find out resistance, pick a voltage and its corresponding current. From graph, and apply. So we can select any value. For example, if you want to find out the value of resistance, so you can choose any value that will give you the current and the voltage of that corresponding point, and we can find out the value of resistance by using R equals to V over I. So this is the concept of Ohm's law and ohmic conductors, right? So for all the conductor that obeys Ohm's law, when their voltage are directly proportional to the electric current, so that will give you the same result. But for non-ohmic conductors, we have different categories. For non-ohmic conductors, So basically for non-ohmic conductor, there are different non-ohmic conductors. And the first that we are talking about is filament. Filament lamp. So basically in filament lamp, it is like the orange bulb that we use before energy savers. So in orange bulb, if you remember, the temperature of orange bulb was very high because it increased its temperature. And when the temperature increases, so the material in that bulb it starts to glow, and that glow gives you light energy. So that is the working of filament lamp. So basically filament lamp works like when temperature increases, resistance also increases. And why this happens? This happens because when temperature increases, so the vibration of atoms increases. Because temperature provides kinetic energy, so that's why the vibration of atoms increases. And when the vibration of atoms increases, so definitely electrons that are moving from conductors one point to another, that will slow down. So electrons slow down. And when electrons slow down, so rate of flow of electrons decreases. So basically, it shows you electric current decreases. So electric current decreases, resistance increases, and voltage also increases, right? Because from the formula of resistance, R is equals to V over I. So resistance is directly proportional to the voltage. So when the resistance is high, so the voltage is also high, and current, the value of current will be low at that time. So this is the concept of filament lamp. It works on the temperature concept. So when temperature is high, so resistance is also high and the voltage will also increase with resistance because both are directly proportional. And let's suppose uh, if we draw graphical representation just like the Ohm's law for this filament lamp. So let's suppose, so in the first graphical representation, let's suppose we are taking current on y-axis, voltage on x-axis. And in second representation, we are taking voltage on y-axis and current on x-axis. And if we talk about the representation, when the value of temperature, as we discussed, when temperature increases, resistance also increases and voltage increases. So it means that your graph bends towards the voltage axis like this. Graph bends towards the voltage axis in this way. And for this representation, we say that when resistance increases, graph bends towards voltage axis. So when resistance is high, so your graph shows representation by bending towards voltage axis. But when resistance is low or when resistance decreases, so in that case, current axis. So the normal nature of the filament is when current increases, so the resistance also increases and voltage also increases. Graph bends towards the voltage axis. So this is the normal nature of the filament. But let's suppose in some question they used to ask that we have filament lamp and the resistance of filament decreases. So draw the graph or what will happen. So then for graphical representation, graph bends towards the current axis and definitely the value of voltage decreases when resistance decreases. So this is the first type of non-ohmic conductor. And we have one question also. Like there are multiple questions in your past paper related to filament, but from the recent papers,
Will there be questions where we have to draw the graphs?
yes,
Okay.
in new papers of this one. In question 6, you can see sketch the current voltage graph of a filament lamp and explain its shape for 3 marks. So it's your choice. First, like the same, if you want to place current on y-axis, it's your choice. Or otherwise, you can plot on x-axis. Then you need to show the representation. Graph bends towards voltage axis. And in explanation, you have to write the same thing. When temperature increases, resistance also increases and graph bends towards voltage axis, right? So in this way, you can complete the representation of the graph, complete the description related to the filament lamp, right? So it is important to remember the graphical representation, the concept of the filament, and the complete idea of the graphical representation for current and voltage in filament lamp, because they can ask any type of question from any non-ohmic conductor. So right now we only discussed about the one. So when we talk about the other non-ohmic conductors, so then you have to also remember the difference between them, because in any circuit you will get any type of non-ohmic conductor, and then you have to differentiate and use the concept according to that in the question. So right now we have only one filament. In next class we will discuss the other components also. Till then, now you can practice the questions from electric current, voltage, resistance, combination of resistance, filament, Ohm's law from MCQ worksheet and this theoretical worksheet also, right? Like in this question we have LED. So definitely you don't know about the LED, so you can skip this question. And if you move towards the other questions, this is related to current and resistors and power. So you can solve this question on page number 133, because it is related to the topics that we studied. So I am mentioning that question. Question on page number 133. You can solve this one, except part C. Then ignore this one. You can also try this one, question 120, page number 129. This is a typical type of question, but uh, you must try by yourself so you will get idea that what are the difficulty in this type of question. So we will discuss this question after non-ohmic conductors also. Page number 122. So these are some questions to practice related to the topics that we covered in electricity chapter. Okay. And in next class, we will discuss some other non-ohmic conductors also. Plus, we also practice these questions if you find any difficulty in these questions and the other questions from the worksheet also. Right.